So we're adding, subtracting, and multiplying radical expressions. To add or subtract radical, the insides must match. So the insides of your radical must match. What I mean by that is if you have like 2 cube root 3 plus 4 cube root 3, the radicals and the insides must match. Do they match? So what's 2 plus 4? So this would be 6 cube root 3. Okay. So if you had something like 2 square root of 2 plus 3 square root of 3, do the insides match? No, so this does not simplify. So that's how this works when adding and subtracting. So if you look at number 1, the insides already match. We have LP cubed, which does not simplify. L is, I mean not L. Why did I say L? 11. 11PQ. 11 does not simplify. It's prime. And they're both fourth roots. So what's 3 plus 7? So there's your answer. Now sometimes they're going to simplify and they might not be able to combine. So if you look here, always use this yellow card. So we have the cube root of 64. If I look at cubes, is 64 a perfect cube? So what's the cube root of 64? 4. So I know that I can take out 4. Now, does 3 go into 4? How many times? With how many remaining? And does 3 go into 5? How many times? With how many remaining? So that is what the left simplifies to. Now I'm going to bring down that minus sign in the middle. Now, do you remember, can an odd root have a negative on the inside? Yes. So when you have a negative on the inside of an odd root, you just take it out. Okay, it's even roots that become imaginary. Okay, but this is an odd root, so that's fine. 27 is a perfect cube, so what's the cube root of 27? 3. Now 3 goes into 10 how many times? 3 times. With how many remaining? 1, because 3 times 3 is 9, to 10 is 1 more. 3 goes into 14 how many times? So 3, 6, 9, 12, so 4 times. And that's with 12, so 13, 14, you have 2 remaining. Now, do my insides match? Yes. What do I do with this double negative in the middle? It does. It becomes plus sign. Now, are these like terms? No. They have the same letters, but they have to have the same powers to combine, so do they get to combine? No. So, however, you can leave your answer like this, or you can rewrite it, which technically, to put it properly, this should go first, so I'm going to rewrite that in front, because it has a higher degree. So you could write it like this as well. So the inside has to match, but this one's weird because it had letters that came out that did not match. So that's why this one didn't combine. Okay, number 3, we're going to change this problem a little bit. We're going to change it to 75 to the 1/2 power minus 147 to the 1/2 power, not to the 1/3. Okay. So, do they Simplify. Well, if you were to type this in your calculator, because there's no letters, so 75 to the 1/2 power, that's not what I meant to do. Gives me a decimal, so that's not pretty, meaning I'm going to have to break this apart. So I need to rewrite it in radical form. Well, what's my root here? 2. So this is the square root of 75 minus the square root of 147. Now, do you have to label square roots? No. So if you didn't put 2's, are you okay? Yes. Now, I'm going to have to break these down. I've already proven in my calculator that 75 is not a perfect square. You could do the square root of 147, but if you look here, it's also not a perfect square. So I'm going to have to break both of them down. So 75, well, what goes into 75?
5.
So 5 does how many times? 15. 5 also goes into 15 3 times. So it's a square root, so I need something to match twice. So I have the 5 that matches twice. And what stays on the inside? So this gives me 5 root 3 minus, and now we have to break down 147. 147 doesn't break down as easy. I know 2 doesn't go into 147 because it's odd, so I'm going to try 3. Well, 3 did 49 times. And 49 is 7 and 7. So look, 7 comes out. And what stays inside? 3. Now, do they have the same root and the same insides? So what is 5 minus 7? Negative 2 square root of 3. Because 3 is prime, so you can't break that down. Okay, look at number 4. So what's different about number 4? Yeah, which means what? Which means what? Multiply. So, what I want you to realize is this the same thing as 1 square root of 3? Yes? So what's 1 times 5? So this becomes 5 square root of 3 because square root of 3, there is no square root over here, so it doesn't change. Okay, so what rule did we learn a couple days ago? Watch, I'm going to show you. We learned these rules. Okay, we learned that dividing can be separated, but it can also be put together. We also learned multiplying. If they have the same root, they can be combined and multiplied together, yes? So, do these have the same root, the 3 and the 30? They're both square roots. So, can I combine them and put them together? So, what's 3 times 30? 90. So, this becomes the square root of 90. Well, 5 square root of 3 doesn't simplify, but we need to simplify this 90 because we don't know if it can combine. So come over here. 9 is 9 and 10, which would be 3 and 3, and then 2 and 5. So what am I going to take out? And what stays inside? Yeah, 10. So this becomes 5 root 3 plus 3 root 10 does not combine because they are not the same roots. So there's your answer. Huh? Sure. But that's your answer. Because you did simplify it. Yeah. Okay, so we have this one. 5 is simple. Okay, we can combine because they're both square roots. Ooh. So what's 5 times 2? Now, my letters aren't the same, so they're just going to come next door to each other. And this is a square root because it's not labeled, so you could put the 2 if you need to. Some of y'all, that benefits you when it comes to the letters. Now, we could try to break down 10. The only thing that multiplies to give you 10 is 2 and 5. Does that mean I get to take any numbers out? No, because nothing matched. So the 10 is going to stay on the inside. Now, does 2 go into 3? How many times? With how many remaining? Does 2 go into 2? Once. With how many remaining? None. So there's your answer. You sure? I just put them in alphabetical order because that's proper. Kinda. Okay, look at number 6. What does squared mean? Not multiplied by 2. Multiplied by the same thing twice, right? Now this has a plus sign in the middle, so I can't do power to a power, which is what we've been doing when we have something like this. But when you have plus or minus in the middle, you can no longer do that. You have to double distribute. So I always cross out my squared and I write it again because I don't want to write it twice. Now I only have to write it once. So isn't that the same thing twice? That's what squared means. So I have the same thing twice. And I'm going to double distribute. So what is 4 times 4? Now, 4 times 3 root 6. Well, 4 is on the outside, so what's 4 times 3? 12. And there was no other root, so this just stays root 6. Are we okay with that? So then we have 3 root 6 times 4, which is the exact same thing. So that also gives me 12 root 6. And then this is the one where it gets weird. We have 3 root 6 times 3 root 6. Well, what's 3 times 3? 9. And what we have the root of what's 6 times 6? 36, which is also just 6 squared. So you can write it as 36. You could also write it as 6 squared. And now we need to simplify everything if possible. Well, does 6 break down to 2 and 3? So 6 doesn't break down. However, these are like terms. So what's 12 root 6 plus 12 root 6? 24 root 6. Now this breaks down. What's the square root of 6? I mean 36? 6. It's a perfect square. That's why I was saying you could write it as 6 squared because then the square root cancels the squared. So what is 9 times 6? It's 54. And now what's my last like terms? 16 and 54, and what does that give me? And those don't combine because 70 doesn't have a root 6, so there's your answer. Okay, 2 more. Bear with me. Okay, look at number 7. So we're going to multiply. What's the square root of 2 times the square root of 8? Square root of 16. Square root of 2 times negative 5. Negative 5 square root of 2. Because remember, this is the same thing as 1 square root of 2, and you multiply the numbers on the outside together and then the inside together, so there was no other inside. So positive 3 times the square root of 8 is just positive 3 square root of 8. And then 3 times negative 5 is negative 15. So after we're done multiplying, we simplify anything that we can simplify. Well, what's the square root of 16? It's just 4. Remember, you can use your handy dandy sheet that I dropped. So 16 is 4 squared, so it's just 4. Okay. Now, 2 is prime, so this doesn't simplify, so I'm going to go ahead and bring it down. Now, 8 is not prime, so I can try to break it down. I get 2 and 4. And 4 is 2 and 2. Well, this is a square root, so I can take out a 2. Well, there's already a 3 there, so I can't forget that the 3 is still there, and I can put a 2 in the house. Well, what's 3 times 2? So this becomes plus 6 root 2. And then minus 15 doesn't simplify. Now, what are my like terms? So what's 4 minus 15? Negative 11. And then are these like terms? And what's negative 5 root 2 plus 6 root 2? So plus 1 root 2. However, I want you to realize you could also write this like this. You don't have, just like with a variable, you don't have to put the 1. But because of that, what I want you to realize is that if you have square root of 2 plus the square root of 2, what does that equal? How many do you have? So it would be 2 square roots of 2, because it's the same thing as 1 plus 1. Does that make sense? So you can always put those 1s there, whoop, if you need it. Yeah? Okay. So last one, example 8. And then you can work on your practice. So we are going to multiply. Everything's inside a house, so everything's going to be multiplied. So what's the square root of 50 times the square root of 2? Well, what's 50 times 2? 100. Square root of 50 times negative square root of 6. Well, positive times a negative is a negative. And 50 times 6 is 300. Square root of 27 times the square root of 2, excuse me, both positive, so plus, is positive 54. And then the square root of the square root of 27 times the square root of 6, positive times a negative is a negative, and that gives me 27 times 6, 162. And now we have to break them all down. So are any of these perfect squares? Which one? 100. What is 100? What's the square root of 100? 10. So we can break that one down easy. None of the others are. So you can look, 54 is not on there, 162 is not on there. You can't see all the way up to 300 here, but it's not. Oh, it goes, here's some others, but it's still not 300 up here. It goes 289 to 324. So it's not. None of these are perfect squares, so we got to break them down. So I'm going to come down to the bottom, and I'm going to break them down. Well, 3 times 100 is 300, and 100 is a perfect square of 10 and 10. And this is a square root, so I only need 2 things to match, so I can stop. And that gives me minus 10 root 3. So then I have 54. Which is 2 and 27, 3 and 9, 3 and 3. So I have 3's that match, but I have a 3 and a 2 left over. So I get 3 root 6 because I multiply the 2 things that didn't match. I'm going to bring down my minus so I don't forget, and I have 162, which would be 2 and 81. 81 is a perfect square of 9 and 9. So minus 9 root 2. Do any of those match? No. So there's your answer. Now I will tell you on your practice, I believe all of them match or have something that matches. So you don't have to worry about like doing a bunch of work for nothing on your practice. Yes? Okay. So you're working on your practice. If you have questions, you can ask. I will have the answer key up here posted.